All right, welcome back. This is the discussion for section 5.4, which is on simplifying radicals. So let's dive into it. Questions asked were, starting with number 1. And it says to simplify completely, and we're given the square root of 7 multiplied by the square root of 14. Individually, there's not a lot you can do with this. The square root of 7, the 7 can't come out. The square root of 14, which is just 2 times 7, nothing can come out. But if I have the square root of one thing times the square root of another thing, I can rewrite this as the square root of those two things multiplied inside a single radical. And this becomes more helpful, right? And instead of multiplying these and getting 7 times 14 would be 98, instead of doing that, break down the 14 and just write this as 7 times, but 14 is just 7 times 2. And now we can see I have a pair of 7s that I can pull out of this square root, so I will. The 2 cannot come out, so it stays in, and that's all I can do to this thing. But I have indeed simplified it, I end up with 7 root 2, and that's that. Okay, let's look at number 2. Let's not look at number 2. Number 2 is the same thing, it's just a little bit bigger number. So let's go to number 8. Alright, 8 is simplify completely, and I have the cube root of 27. X to the third, y to the sixth. So 27 is 3 times 3 times 3. So I can think of this as 3 times 3 times 3. X to the third is just x times x times x. And y to the sixth is just y times 2, 3, 4, 5, 6 of them, right? And since I'm under a cube root, I need groups of 3 factors. And so I have a group of 3 3's. So that can come out of the cube root as a 3. I have a group of 3 x's, so that comes out of the cube root as an x. And I have a group of 3 y's and a second group of 3 y's. So one y comes out, another y comes out, that's y to the second. And there's nothing left in. Everything was in a group of 3 and it came out, so there is no more cube root. It's just this, 3xy squared. That's it. We're done. Let's look at 9. Again, simplify completely, and we're given a square root of 3xy to the fifth multiplied by the square root of 27x to the fifth y to the third. Again, I'm under a square root, so I can't do a whole lot with this 3, this x. I could simplify my y, but I don't want to yet. What I want to do is take that property that we used in number 1 and just rewrite this as a big conglomerate glob. I have 3, I have 27, so I have 3 times, but I know that 27 is 3 times 3 times 3, so I'm just going to write this out. 3 times 3 times 3 times 3. Right, the 3 from the first one, and then the 27 from the other guy. Okay. I have x, it's going to multiply by x to the fifth to give me x to the sixth. And I have y to the fifth times y to the third, that'll give me y to the 5 plus 3, so y to the 8. Well, I'm under a square root, so I need groupings of 2. So I have a grouping of 2 3's, I have another group of 3's. 1 3 comes out, another 3 comes out, multiplies, that turns into a 9 out here. 6 x's is 3 groups of 2's, right? Divided by 2 you get 3, so I have x to the 3 Same thing, how many groups of 2 of y? Well, there's 4 of them, and so y to the 4th. That was everything, there's nothing left over, no remaining, and so I end up with 9x to the 3rd, y to the 4th. And I'm done. No more root, that's it. Okay. And then let's look at 11. 11, weirdly out of place, is just like question 1. It is the square root of 6 multiplied by the square root of 12. So again, I'm going to rewrite this as, say, 6 times 12, but I'm going to cheat and rewrite 6 times 2, because that's also 12. I have a group of 2 6s that can come out. I have a 2 that's stuck behind, right? I have 6 root 2. I could also break this all the way down, 2 times 3 times 2 times 3 times 2, pull out a 2, pull out a 3. Still ends up as a 6. I still have a 2 left over. At any rate, that's my answer. Alright, hopefully this helped. I'll see you guys for the next one.